Today we are going to learn some basic knowledge about SEM. And this true picture is taken by SEM. This is a diagram compared with optical microscope to SEM. This is the basic structure of optical microscope. It uses light as the source and use glass lenses to control the light and let it insist to the specimen. Well, SEM use electron beam as a source and the magnetic and electric field as the controlled lens to control the electron beam and let it focus on the specimen on the workplace. And then, with the interaction between the electron beam and the specimen, there are some signal will emit out from the specimen, and we will collect these signals by the detector and show these signals on the screen. There are three major signals will emit out from the specimen by the interaction with the electron beam. They are backscattered electron, secondary electron, and X-ray. And SEM is take the property of these three different signals to detect the material. This picture illustrates the interaction volume of these three signals. X-ray have the biggest intervolume. It's the deepest. Well, the backscattered electron is at the middle region, and the secondary electron is very close to the surface of the specimen. Now, we are going to distinguish these three signals. Let's talk about the secondary electron first. It is produced by inelastic interaction of high-energy electron with the valence electron of atom in the specimen, causing the ejection of the electrons from the atom. These ejected valence electrons are termed the secondary electron. Now, let's make it clear. As we all know, one atom is consists with a nuclei and extranuclear electron. For this element, which has three extranuclear electrons, is Li. And when the electron beam comes to this atom, the electron of the electron beam may have a collision with the electron of extranuclear electron. Then the extranuclear electron will get energy from this collision and they will emit out. And this electron is called secondary electron, which is former the extranuclear electron. And this is how the secondary electron produced. How we took advantage of secondary electron. As I just said, the secondary electron have interaction volume very near to the surface of the specimen. Well, the surface of the specimen is uneven. It may have lower part and higher part. And when the electron beam comes to the lower part, it has lower energy to reach this point. So, there are few secondary electrons will emit out. Well, at the higher part, there have higher energy. So there are more secondary electrons will emit out, okay? And after these signals collected by the detector, this is the detector. And shown on the screen, the lower part will have darker color and the higher part will have a brighter color. So we can take this property of secondary electron to detect the morphology of the specimen. This is the backscattered electron. It is produced by elastic interaction of beam electrons with nuclei of atom in the specimen. And let's make it clear. Okay? As I just said, the incident electron beam may have collision with the extra nuclei electron, but still it may not. This is one nuclei of atom. If the incident electron beam directly penetrate and didn't have any collision with the extra nuclei electron. But as we all know, the nuclei is positive charged and the electron is negative charged. So there is a force in between. Because of this force, the incident electron will going back. And this is called backscattered electron. It is a scattered electron. Okay, because of different material or different phase have different arrangement of atom. So this arrangement will make this scattered angle to be a certain one to one material. So we can use this property to detect different phase of material. Finally, let's talk about X-ray. When the incident electron interact with the extra nuclei electron, instead of emit out, the extra nuclei electron from higher energy level may move to a lower energy level. And during this process, X-ray photons will emit out. Up to now, we have already learned 3 signals emitted from the specimen by the interaction with the electron beam. And now, what I will do is to show these 3 signals and how this works on SEM machine. This is the example we used today. Now, I'm going to put it in SEM machine. This is a cross-section view. This sample is consists with a PCB board. This PCB board is 2-phase PCB board. On the top layer, there are resistors, and the bottom layer, there are chips. Okay, now we are in the secondary electron mode. Secondary electron mode is to detect the morphology of the sample. At this point, after we magneticant, we can easily find cracks, also the void and the bubbles. This is how the secondary electron mode works. And now we are changed to the backscattered electron mode. Now we can find the image is totally changed. Because of the deeper interaction volume, the BSE mode image have higher contrast. And this contrast can let us have clear view of the material and the face. Let's focus on a solder joint, which is used to connect the chip to the PCB board. After detecting the solder joint to the copper pad, we have found another material face. This face is shown with another color. So, we can easily find 3 colors on this screen. There are 3 different faces of material. Up to now, we have already successfully used the basket mode to find different face of material. And now we are going to detect the content of this face. To detect the content of this face, we will take advantage of X-ray. Now, I'm going to select one point, and we will collect the X-ray signals from this point. When we collecting this X-ray, we will get an energy peak, and we judge this peak by the researcher's experience and knowledge to judge what it stands for the certain element. For this element, I can confirm it is tin. Now I can totally confirm this color material is a tin-based material. The almost element is tin. And now we choose another point. After collecting this point signals, we can find there are more than 10 peaks shown out. And for this 2 peak, it is copper. Okay, now we can judge. This point is consisted by tin and copper. But what's the content? We can quantify this result. And now we can easily find the atom of this point is copper, maybe copper 1 and tin 2. But in this world, there is no this material, and now we have to confirm this material by our knowledge or information on the internet. Up to now, this section is finished. We have already learned the basic theory of SEM, the 3 major signals: secondary electron, basket electron, and X-ray, and how these 3 signals works in this machine, and how we use the advantage of 3 signals to detect the material. Thanks.